So this is R10. We're going to be solving linear systems with substitution and elimination. So we have system of equations, which means we have two equations with two variables. So yesterday we were just solving one equation with one variable. Now we have two equations with two variables, so we're going to end up with two answers. So it gives us some steps to follow when solving by substitution. We want to solve one of the equations for one of the variables. So we either want one of the equations to be x equals or y equals. So we want one of our variables isolated. Then we substitute the expression from step 1 into the other equation and solve for the other variable. And then we substitute that value, so the answer we get, into the other equation and solve for the remaining variable. So in A, do we have either an x equals or a y equals? We have a y equals. So I'm going to take what y is equal to and substitute it into the y in the other equation. So my second equation is 6x minus 5. Now in the spot of the y, I'm going to put negative 2x minus 9 equals negative 19. Now I have one equation here with one variable. So what would I need to do to solve for x? Distribute the negative 5. So I'm going to distribute negative 5 into the parentheses. So we have 6x. This turns into a plus 10x and a plus 45. What would we do next? Combine like terms. So 6x plus 10x is 16x. What else could we do? Subtract 45 to move it to the other side. So 16x is equal to what? Negative 64. Then what should we do? Divide by 16. So what does x equal? Negative 4. Now this is just half of our answer, because what variables did we start with in our equation? I have to plug it back in to find the y. So we're going to plug it into x. It doesn't matter which equation you plug it into, but since it's x equals, you have to plug it into the x. So I'm going to plug it into the first one. So we have y equals negative 2 times negative 4 minus 9. So y equals 8 minus 9. What's 8 minus 9? Negative 1. Now we write our answer, since we have an x and a y, we write it as kind of like a coordinate point with your x first. The x always goes first, so it's going to be negative 4 comma negative 1. Where we have our x, then y. So this would be our answer. Okay, let's do B. So here, do I have an x equals or a y equals? I have a y equals. So I can take what y is equal to and substitute it into the y in the other equation. So we have 3x plus 14 is equal to negative 4x. I can subtract 3x from both sides. Awesome. Then I have to divide the negative 7. So 14 divided by negative 7 is? So negative 2 is equal to x. Am I done? I have to plug it in to find y. Which equation do you want to plug it into? I'm going to plug it into the second one just because it looks easier to do the math in. But again, it doesn't matter which one you plug it into. You'll end up with the same answer. So we're going to take negative 2 and plug it into the x. Just make sure, since it's x equals negative 2, you're plugging it into the x. So I have y equals negative 4 times negative 2. So what does y equal? 8. How would I write my answer? Negative 2 comma 8. Remember, it's always your x, then your y. All right, let's look at C. Do we have an x equals or a y equals here? A y equals. So I'm going to take what y is equal to and substitute it into the y in the other equation. So I have 3x plus 2 times 1/2 x minus 1 equals 0. So just take y and plug it in to the other equation. Now I only have x's in my equation, so I can solve for x. What would we do first to solve for x? Distribute the 2. So what is 2 times 1/2 x? Just x. Awesome. And 2 times -1? -2. So we have 3x plus x minus 2 is equal to 0. What should we do next? What's 3x plus x? 4x minus 2 is equal to 0. We're going to add 2 to move it to the other side because we want our variables on one side, the constants on the other. So I'm going to add 2. 4x is equal to 2. And then what? Divide by 4. So what does x equal? 1/2. Am I done? What do I have to do next? I got to plug in x to find y. Do you want to plug it into the first equation or the second? We can plug it into the second. Doesn't matter which equation, just make sure you're plugging it into x since it's x equals. So we have y equals 1/2 times x was 1/2 minus 1. All right, we're solving for y now. What would I need to do? What do I do next? How do we multiply fractions? Straight across. So 1 times 1 would be 1, and 2 times 2? 4. So we get 1/4 minus 1. How do I add and subtract fractions? What do I need? Same denominator. So I can make this 1/1. And how do I make it have a denominator of 4? Multiply the top and the bottom by 4. So we would change to 4/4. Then we just combine the numerators. So 1 minus 4 would be -3. And the denominator stays the same. So how would I write my answer? 1/2 comma -3/4. Perfect. The x and then the y. All right, let's look at D. Do I have an x equals or a y equals? We have an x equals. So I'm going to take what x is equal to and substitute it into the x in the other equation. So here we have 4 times 6y minus 7 plus y is equal to -3. Here we're solving for y first. What should I do first to solve for y? What would I do to the parentheses? I'm going to distribute the 4 into the parentheses. So we have 24y minus 28 plus y is equal to -3. What would we do next? Combine like terms. So I have 24y plus y, which would be 25y. What else could I do? Add 28 to the other side. We want to move the constants to one side, the variables on the other. What's -3 plus 28? 25. What would we do next? Divide by 25. So y equals 1. Are we done? What should I do next? We can plug it into the first one. Am I going to plug it into x or y? Plug it into y since it is y equals 1. So we have x equals 6 times 1 minus 7. 6 times 1 is 6. And 6 minus 7? Negative 1. Brian, how would I write my answer? Try again. The x comes first. Negative 1, comma 1. So be careful, the x always comes first. All right. The second way that we can solve systems of equations is by elimination. So when we solve using elimination, we can possibly start by multiplying one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficient. So what we need is the same number but opposite. So if we're using elimination, if I had something like 3x, I would need negative 3x in order to cancel out. We need one of our variables to eliminate. So they have to be the same number but opposite. So in order to do that, we could multiply. Sometimes we don't have to, but sometimes we will. We're going to add or subtract the equations to eliminate one of the variables, and then solve the resulting equation, and then plug it back in to find the other variable. So again, to start, we need the same number but opposites, meaning one's positive and one's negative. It doesn't always have to be the x's, it could be the y's. So for A, we are solving by elimination. Do I have the same number here but opposites? With which variable? The y. Because I have a positive 2y and a negative 2y. So are these going to eliminate? Yes. So we don't have to multiply anything to start. We can just go ahead and combine our equations together. So I'm going to add all of my like terms. What's 3x plus 3x? 6x. What's 2y minus 2y? They cancel out. We said that they're going to cancel. So when we're combining our like terms, one of the variables always is going to be eliminated. What is 4 plus negative 4? 0. What would I do next? Divide by 6. And what does x equal? 0. 0 divided by 6 is 0. So x equals 0. That's one of our answers. How would I find y? Plug it in. Do you want to plug it into the first equation or the second? Sure. We can plug it into the first. It doesn't matter. You'll end up with the same answer. Just make sure you do the work right. So we're plugging it into x. So we have 3 times 0 plus 2y is equal to 4. What's 3 times 0? 0. So it's just 2y is equal to 4. Daniel, what would I do next? Machado. Divide by 2. So what does y equal? 2. Cody, how would I write my answer? 0 comma what? 2. Perfect. Remember, x always comes first. For B, do we have the same number but opposites? With which variable? The x's. So we're going to eliminate the x's. So we're going to combine all of our like terms. 3x minus 3x, we said they cancel. 2y plus 4y, 6y, and 7 plus 5, 12. Christian, what would I do next to solve? Divide by 6. So y equals 2. Am I done? What would I have to do next? Plug it in. What am I going to plug it into? We can plug it into the first one, into x or y? Into y, because it's y equals. So we have 3x plus 2 times 2 equals 7. So 3x plus 4 equals 7. Cody, what would we do next? I already plugged it in. Subtract 4. So 3x equals 3. Then what? X equals 1. How would I write my answer? 1 comma 2. Perfect. Don't forget the x always comes first. All right, let's do A. So again, these say solve the system of equations by elimination. So our goal is to get the same number but opposites for one of our variables. Do I have the same number but opposites? No. Can I make one of them the same number but opposites? Which one do you want to make the same, the x's or the y's? Let's do the y's. What would I need to multiply into which equation to make them the same number? I'm going to multiply the top one times 2. Bless you. When we multiply the top number times 2, that gives us a positive 6y, which is exactly what we're looking for, the same number but opposites. So I'm going to rewrite it on the right here just so we have some more room. That 2 gets multiplied to everything in our first equation. So it becomes negative 20x plus 6y is equal to 2. Do not forget to multiply it to the other side of the equal sign. That's one of the most common mistakes that people make here, is that they forget to multiply it to everything. I'm going to rewrite my second equation right below it just to make it easier for us to combine. Do I have the same number but opposites now? Yeah. So we're going to combine all of our like terms. What's negative 20x minus 5x? Negative 25x. What happens to the y's? Cancel. And 2 plus 23. 25. What would we do next? Divide by negative 25. So what does x equal? Negative 1. We're done?
Why did you put the 2 there? Like you did 2 and
Because we wanted to multiply the first equation by something that would give us the same number here, but opposites. Because we want to use elimination, so we're looking for a variable that has the same coefficient, but one's positive and one's negative. So we had to multiply to get it to be the same. So if you don't start off with the same number but opposites, you can always multiply. You can multiply one or both equations if you need to. So we got x equals negative 1. How do we find y? Do you want to plug it into the first or the second? Let's plug it into the second. Again, doesn't matter. It doesn't matter. You could plug it into the x here, you could plug it into the x here, or the x here. I would suggest doing it into one of the original ones just because the numbers are going to be smaller. But you'll end up with the same answer if you plugged it into like your new first equation too. So let's plug it into the second equation. We have negative 5 times negative 1 minus 6y is equal to 23. What would we do first? Multiply. Negative 5 times negative 1 is 5. What do we do next? Subtract 5. So negative 6y is equal to what? 18. Then what do we do? Divide by negative 6. So what does y equal? Negative 3. Sebastian, how would I write my answer? Negative 1 comma negative 3. Perfect. For B, do we have the same number but opposites? Nope, not yet. So let's make them the same number but opposites. How can we do that? What do we need to do? Which one? Yeah. We could do that. It doesn't matter. There's more than one way, more than one right way to do this. You can multiply the top one by -3 and get your x's to cancel. Or we can multiply the bottom one by +3 and get the y's to cancel. Doesn't matter. So let's multiply the second one by 3. So our new second equation would be what? 9x plus 3y equals 36. Perfect. That 3 gets multiplied to everything in the parentheses there. Everything in our equation. I'm going to rewrite my first equation on top of it just to make it easier for us to combine. So now we're going to combine our like terms. What's x plus 9x? 10x. -3y plus 3y cancels. 24 plus 36. 60. What do we do next? Divide by 10. So what does x equal? 6. What do we do next? Plug it back in. What are we going to plug it into? We can plug it into the first one. It doesn't matter. Just make sure you plug it into x. So we have 6 minus 3y equals 24. If you want to plug it into the second one, see if you get the same answer, you will, if you do it right. Now we want to solve for y. So I'm going to subtract 6 on both sides. Yeah. So -3y is equal to what? What's 24 minus 6? 18. Divide by -3. So y equals -6. How would I write my answer? Six comma -6. Perfect. Okay, for C. Do we have the same number but opposites here? No, not yet. So we're going to have to multiply to get them to be the same. Do you want to eliminate the x's or the y's here? Just pick one. Which one do you want to do? We can eliminate the y's. So I need my y's to be the same number but opposites. So what do I need to do to multiply to get my second y to be a -4? Times -4. So we have to multiply that to everything in the second equation. So what's my new second equation going to be? -52. Perfect. Now I'm going to rewrite this first equation right on top of it just to make it easier for us to combine. So I have x plus 4y equals 22. Let's combine our like terms. What is x minus 16x? -15x. What happens to the y's? They cancel. What's 22 minus 52? -30. What do we do next? Divide by -15. So x is equal to what? 2. What do we do next? Plug it back in. Do you want to plug it into the first or the second equation? Let's plug it into the first. Just make sure you are plugging it into x. So we have 2 plus 4y is equal to 22. So now we're solving for y. What would we do? Subtract 2, so 4y is equal to 20. What What do we do next? Divide by 4, so y equals 5. How would I write my answer? 2, 5. Perfect. So sometimes it'll tell you solve by substitution or solve by elimination. Remember, we want to solve by substitution if it starts off with y equals or x equals, or if it's easy for us to get a y equals or x equals. And for elimination, we want to use that if it's the same number but opposites. That way one of them will eliminate itself. So if it tells you which method to use, just do whichever one. But if it doesn't, you may want to look for either one of these to tell you which might be easier.